Hey guys, in this tutorial we'll be talking about the new collision detection system for ESPRIT TNG. First things first, you guys would want to go into your security manager and go ahead and reactivate your ESPRIT TNG license. This is so that collision detection will be enabled. Alright, so with the new collision detection system, we overcome four major flaws that we had in the previous TNG or previous ESPRIT builds. So one of the issues was the toolpath of the operations used to always have to be recalculated for you to see the collision detection, and now that's not the case. You can do it on the fly. Another problem we had was collision detection was only available for your mold cycles. Now it's available to all your milling cycles. As you can see here, all your 2.5 axis ones, like this pocket here, you can see collision detection. Another issue we had was collision detection only looked at your freeform feature and what you had defined under your part and check section. It never looked at your part setup in a whole like we do now. And lastly, there was really no quick way to determine whether or not there was a collision. Now you can see here, if I'm in the part manager, you can see these green balls here. These pretty much tell me whether or not there is a collision for that part. Alright, so let's go ahead, open up collision detection.esprit. Now to see your options for collision detection, go ahead and go under File, Options, and then in the options under Machining, you will see the collision detection settings that are provided. For part geometry tolerance, it's defaulted at 5/10, or 5/10 I should say, and then if you are on inch, it would be at 2/10. Cancel here. So in this file, you can see that if you hover over these green balls here, this is pretty much the collision detection system. It'll tell you whether or not there are any collisions for that operation. Okay, it'll tell you your minimum tool length, tells me if I'm checking against the stock, checking the GDML holder shank clearance as well as the holder clearance. Alright, so in this first test, let's force a collision. So first things first, let's go under our work planes. Let's select facing _y positive. Let's go to our layers drop down and let's click on pocket. So we can see this pocket here. That's where we're going to force a collision. So go ahead and select the feature for the pocket here. It should be 19 pocket. Let's go ahead and right click, copy. And let's select translate. Make sure this is set to move instead of copy. And we'll want to translate this using X, Y, and Z with Y set to 10. So just shift everything over to the left here. Now, a couple things that I noticed is that this ball that was green is now gray. So what it's saying is the state is not checked for collision, for the collision detection. So if I go ahead and select that operation, I'll right click onto it, and then down here you'll see collision detection. Go ahead and click that. You'll see these settings here. These are the default settings set in the Files Options menu. Go ahead and click on OK. Now we can see that this ball is red. Okay, it's telling me that there is a collision. What you'll also notice is that the passes that have a collision, you will see that they turn red here. Okay? So it knows that there is an issue around. Before you couldn't see where the collision was happening, now you can with ESPRIT TNG. Also, if we look at the output window here, this operation down here, there is a collision. So I'm just going to right click this and then I can hit clear to remove anything in the output window. Also, if you don't see the output window, F3 is the hotkey for it. Just going to go ahead and hide this. Alright, let's go on to experiment 2. Let's go ahead and just reopen this file. So for this, let's go back to our part manager. Alright, we can see some of the stock automation is still calculating. For tool T4B7, let's go there. And what we're going to do is change the overall length to be the same as the tool length, so we'll be shortening it essentially. Make sure you're also under the extension option or tab. And put in 60, hit OK. So what happened is when I changed my tool, all the operations that are affected by that or are used by it, they are going to tell me that the collision is not checked. Okay? So what I'm going to do is I'm going to shift click. I'm going to click swarf, hold shift, click on composite so I get all the operations selected between them. I'm going to right click anywhere in these operations. I'm going to click on collision detection. So you can see here there's multiple shank clearance settings for each of those operations, and then the other settings are set by the file options menu. Go ahead and click on OK. So what we can see here is that the only one that causes a collision is the composite cycle. Okay, so this operation here. So we can actually see the passes that actually cause a collision, so it's down here. So if we go onto the composite cycle, we'll go under analysis. We'll go under toolpath. Okay. So we'll have this here. What we're going to do is pretty much look at what's happening, why it's colliding. So we'll go all the way down. Pause it a little bit. I'm going to clear the trace. Let me step it back. Clear the trace again. You can see this is where it's colliding with the holder. You can also see in the output window, if you hit F3, you can see when on the other operations where we check collision detection, there was nothing there. But for the composite cycle, you can see that it's requesting to have a minimum tool length of 62.837 to avoid collisions there. Also some various other things that you can see. It's warning you why it's colliding and what your current settings are at. Great, let's go ahead and do another test. Reopen the file again. Alright, let's go to our part manager here and let's select swarf 5 or number 5 swarf. Let's just go ahead and double click it. So all we're showing you here is that the collision detection set here if I say check and report collisions, these settings are still the same that you had under File Options. Go ahead and hit OK. And then as you can see in the output window, it's still telling me the same thing. That operation does not have any collisions. So let's go ahead and reopen this file again. So in this test, we're going to show that collision detection also takes into consideration your stock allowance. So what we're going to do is go under your part manager and go ahead and click on this number 8 concentric. And in the operation, we're going to set stock allowance on walls to negative 100 thou, as well as this to negative 100 thou. And then under collision detection, let's set this to check and report collisions. Let's leave these settings at default and click on OK. So what we can see here is now, because we have a negative stock allowance, it's still not recognizing any kind of collision, which is good, which is what we want, because we want it to be cutting into the part. You can also see in the output window what it's saying for it, no collisions detected, because now we know that it is cutting into the part. So that sums up this tutorial. If you guys have any further questions, go ahead and send us an email. Have a good one. Bye.